Okay, good morning, ladies and gentlemen. Welcome to the visiting lecture today with University of Custom and Finance from Ukraine. Welcome to the Honorable Miss Olena Parshyna as a Doctor of Economy, Professor Academician of Academy of Economic Science, Professor of Cybersecurity and Information Technology Department. As the topic for today, methodology of scientific research, elements of the scientific methods. Today's session is being streamed on University STEKOM YouTube channel. And for first session, we will start with class presentation by Miss Olena and continue with the Q&A session, time for picture and closing. Okay, let's begin. We will start with the class today. For Miss Olena, the time is yours. Thank you.
Okay, 1 minute. This is my presentation. I change my screen. Can you see my presentation?
Yeah.
Okay. First of all, I can say to you, thank you for this opportunity to take part this my lecture. About my practice and my science in this area, methodology of scientific research. And I would like to say about elements of scientific method. And I can say about my plan. I prepare for you some parts for this lecture, some parts of interesting elements. First of all, I would say about methodology and about some important determinations and about these methods, scientific methods, and many interesting examples in this area too. So I propose to say about methodology of scientific researches and elements of scientific method. First of all, according to my topic, I would like to say about this plan. For example, you can say, for example, about basic methodology and basic determinations in this area. And second part, I would like to say and analyze many elements of research method. And next, about some points from methodology. For example, to say about pragmatic schemes of scientific researches. For example, you can see this first part. Maybe we can say about some theory and analyze many determinations from this area. For example, like basic determinations. For example, first of all, I have prepared next view. For example, first we can start by using the basic determinations, by using the first point, and next algorithm for this lecture. You can see main determinations, and in this part of my presentation, you can see main components about this topic, for example, the basic determinations. First of all, I propose to say about science. You can see this in red color, and step by step, I propose to say about scientific knowledge, next scientific research, next part about scientific method, and methodology. First of all, to say about science. What about science? Formulating needed knowledge. We can use science, and we can use this word knowledge. And we can say is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. So, for example, we can say about science in different fields. For example, we can say science in technical fields, in technical areas. Next, we can say about economic science. For example, I am doctor in economic science, and I have a level in technical science too. For example, cybersecurity. And about economy and about this economic science, I would like to say some experience and some methodology for research economic system. As a complex system, and we can say about some structure, we can analyze like example, for example, a country, and we can analyze development of country by using many levels. For example, we can analyze first of level, its level on enterprises. For example, in different area too. For example, we can analyze economy on the regional level, for example, and analyze different fields, for example, buildings and financials, social area, chemical area, and others. On the next level, we can analyze, for example, country. And for example, our country, we can analyze on different regionals. First of all, for example, we can analyze situation in Dnipro region, in Kyiv region, Kharkiv, and others regionals in our country. Next approach for analysis, we can analyze by using different fields. For example, we can analyze buildings area, we can analyze communications and information technologies, and next we can analyze industry in different fields too, for example, and others. For example, we can use many indicators for analysis situation in this field. For example, we can use many indicators, volume of productions, for example. Next, we can analyze domestic product, for example, and others. We can analyze, for example, situation of this energy and material resources, energy resources, and others. For example, we can say about many functions, and we can use many indicators for forming different functions. And by using this function, we can describe situation in every region and in our country too. For example, this method we can use for analysis situation in economic science, for example, by using this complex system like system on the regional level and on the country level. So it's our first approach about science, and many examples we can say about knowledge in different fields. Next, I propose to you to use about scientific knowledge, like next example. For example, before that, I can say about interesting approach by using mathematical approaches, for example. And for example, these questions you can see on my slides. What do the scientists use for building knowledge? And by using this example before the slides, you can say about these approaches like mathematics, for example. And mathematics is essential to the science. It's important, for example, we can use many important functions of mathematics in science. And we can say one important function of mathematics in science is the role it plays in the expression of scientific models. For example, we can use this example about development of our country. Moreover, we can use these approaches for analysis development of other countries too. For example, we can form production functions by using information about material resources, energy resources, labor resources, and others, and analyze the situation, this information about volume of production on different levels of economic system. And we can form production functions, and by using this function, we can compare development in different levels of this system by using information about subsystems, for example. And next idea, we can use information about development on the level of our country, and we can compare, for example, this information, and we can compare, for example, Ukraine with Poland, Germany, and other countries, for example, like this. This method by using mathematics, and today I propose to you to say about these approaches by using many mathematical functions for forming production function, for forming different function for analysis and development, and to form the level of development in economic, and we can use these approaches for analysis technical system too. Next, you can see, for example, other approaches for analysis science. I propose to you to say about scientific knowledge. Next, scientific knowledge. For example, many questions to you, maybe from students, we can say, what can you say about scientific knowledge? What can you say? Okay. Okay. I can continue about this information about scientific knowledge. We can use, for example, next determination. Scientific knowledge is research which is characterized by special purpose and the main things of reception and check of new knowledge. So, by using mathematical approaches, by using maybe social approaches in social for analysis social system, and another by using different approaches, by using economic indicators, we can analyze situation in different systems. I see. Maybe. Okay. This chart I check. Okay, so we can analyze different information in other systems and other system. I think about technical, social, and economic system. So by using, for example, many approaches, for example, by using information and by using functions, mathematical functions, we can form new knowledge. For example, we can form some functions and we can use these mathematical models for analysis economic system and social system, and moreover we can analyze more indicators for another social and economic systems. Next, we can say about one moment. one moment about important things in scientific knowledge. Scientific knowledge is important. We can say about that because it allows us to understand ourselves and the physical world we live in. It also allows us to improve many aspects of our lives or another situation for mitigate threats for our survives, for example. And like this example, for example, by using a problem in our world, scientific knowledge examples we can say about COVID-19 vaccine, for example. It's very important research and discovery of this COVID-19 vaccine to fight coronavirus is a product of scientific knowledge. I think it's more important examples for currently, for example. And next, for example, we can say about scientific knowledge is a collection of reliable new information about physical world, for example. First of all, we can say for a different system, we can divide it, for example, our world on a different system. This approach, economic system, technical system, social systems, and others. For example, we can combine this system and analyze on a more interesting level. For example, for our society in general, we can use this approach to analyze economic indicators and social indicators. By using these approaches, we can analyze social and economic system for our society in general. So it gains through the intensive process of data collection, experimentations, and analysis. So for forming some base of scientific knowledge, we need to analyze many indicators. We need to form maybe information databases. After that, we need to analyze many processes to form experimentation. Maybe we can repeat some analysis and to use many information for analysis and scientific method for analysis of these databases, this new information. And after that, for analysis, after using scientific method, we can analyze and we can form new knowledge, this new information. For example, like example before this slide, we talked about analysis, economic development, social development, for example. We form by using many long of term and for example during some years and we can form many indicators, this social and economic information about our society in general, about our country. And after that, we can use mathematical approaches for analysis many functions. For example, we can form some functions for analysis development, like information production function. After that, we can use this model. We can use mathematical program soft, and we can analyze situation in future. For example, we can change time, for example, and by using this function, we can analyze situation in future. So by using these approaches, we can form new information and we can analyze. After that, it's our base. We can form this base for decision making in future, for example. So by use analysis, many information, after data collection, after analysis, we can form new knowledge. Next, for forming this new knowledge, I propose to you to say about a scientific research. Next slide, for example, I propose to say about a scientific research. We can say about a system of concepts, law, and theories. And scientific research is purposeful knowledge of the reality, which results acts in the form of system of concepts, laws, and theories. So by using this information, we can form new concept, for example, about development of country, and we can analyze situation in society in future. Another, we can form theory for analysis and for forming new knowledge, and others, for example. So by forming this knowledge, by forming new knowledge, we need to use scientific method. For example, on this slide, you can see, for example, scientific method or simply scientific method. We can use sometimes these approaches. Is a system of techniques for investigating phenomena by using new knowledge or correcting and integrated previous knowledge. So, for example, we can say about idea. We can, like example, we can analyze many indicators, and for example, our idea, we can describe this information by using, for example, linear function. It's simple function. And in simply, for example, simply scientific method. And we can analyze situation by simple function, linear functions. Another idea, we need to compare, for example, this simple function, this more complex integrated maybe method. For example, we can analyze and we can form function of development of our country, and we can use another approaches. We can use mathematical method for analysis, for example, and for forming more complex function, non-linear function. So by using these approaches, we can use more complex scientific method. Another idea, we can use, for example, for forming linear function for some area, for example, for building area, for communication and information system area, for other components of industry. And another idea, for example, on the next level, we can combine many linear function in one complex function. So it's more complex approaches, and we can analyze this forming more complex functions for analysis. Another idea, for example, for forming non-linear functions, for example, for building area, for example, we can use linear function. For communication and information system area, we can describe this area by using non-linear function. And for others, for example, for chemical area, for financial area, for social area, we can use linear and non-linear function. And on the next level, for describing development of our country, we can combine different function, linear, non-linear, and others. Maybe in general, we can say about non-linear functions, this complex function for analysis. But using a method, for example, we can use different mathematical program soft. For example, I think it's not problem for using Excel. Another more complex program soft, Matcat, MATLAB, mathematics, and others. So we can use these approaches for analysis different subsystems, and by using this information, this forming new knowledge for analysis more complex system and analyze situation in future, for example. For forming new knowledge, after using, for example, some scientific method, we can say about more complex problem, for example, about methodology. So, about methodology, we can use its very important aspects for analysis different systems, for analysis different problems and other complex systems, for example. Methodology is usually a system for solving a problem. With special components such as phrases, tasks, methods, techniques, and tools. For example, we can combine, for example, some idea for analysis. We can form many tasks for analysis and for decision making by using this methodology. We can use different methods for analysis. We can form many interesting techniques and tools, for example. Like example about analysis or development of complex system like social and economic system. As example for our country, maybe regional. For example, it's many interesting information about forming many indicators, and we can use for analysis of these indicators many approaches for analysis and by analysis, for example, indicators for social, for techniques, for economics indicators, and others. Tools, we can use different tools for analysis. For example, we can use a different program soft by using some approaches, this Excel and other ideas by using Matcat, by using mathematics and MATLAB, for example. So methodology can be considered to include multiple methods, each as applied to various aspects of methodology. For example, like example about country, we can analyze by using, for example, analysis with many indicators. And these indicators can describe various aspects of our system, complex system. So after analysis, for example, by using scientific research, by forming scientific method, we can form and we can say about forming of a methodology. And on the next step, we can say about two main parts of research. For example, can be divided between two parts, and we can say about these main two parts. For example, we can say about qualitative research and quantitative research. So for first, we can use indicators qualitative indicators. Sometimes we can use indices. And for next part, we can use quantitative indicators or indices, for example. And after that, very important to analyze situation by using quantitative. We can use mathematical methods, but for qualitative, we can use some methods for using and for changing these qualitative indicators and indices to quantitative indicators and indices. It's very important approaches. After that, we can use mathematical models, and we can form some functions and analysis these indicators by using mathematical methods. Next, I propose to say about important elements of scientific method. For example, the scientific method is the means by which researchers are able to make conclusive statements about their studies. For example, the result of new study and the interpretation of data. For example, we can analyze development of our country, maybe another country. We can use information about quantitative indicators like expensive of material resources, energy resources, labor resources, and others. Next, we can analyze, for example, volume of production in every field of our country. Next, very important to analyze, for example, this indicator GDP. For example, we can use this information for analysis during some years. And after that, for example, by using indicators about resources, by using indicators about volume of production, maybe we can add information about profit in every area. We can form some production function for analysis situation in this area, and we can analyze situation for future too, for example. This example for interpretation. After that, we can use mathematical models by using this production function. After that, we can say about interpretation of this data for future. We can say about economy in general. We can say about level of rise of economy, and maybe we can compare tendency in different areas and analyze situation in country in general. Next, about forming these approaches, we can say about different ways of describing the basic scientific method. For example, we can say about methodology in general, but very important to say about some methodological elements, and we can say about organization of procedures. So there are different ways we can say about that. We can use different ways of describing the basic scientific method. For example, the scientific community and philosopher or scientific general agree to the following classification of components. They say about first components, methodological elements, and second part, organization of procedures. It's very important because we can say about different approaches. We can use many interesting methods. We can use Currently, for example, we can use different program soft for analysis, but very important how we can do that, how we can use, for example, what can we do on the first step, what can we analyze after first step of our researches, and step by step we can divide it our work and say about stages of our researches. It's very important for analysis and for organization of our researches. For that, I propose to say about methodological elements and organizations of procedures. On this slide, we can say about characteristics, we can say about hypotheses, about predictions, and experiments. And according to this idea, I propose by using the same idea to say by using next. For example, first, characteristics, and in my slide you can see these 4 components. And according to the first, characteristics, we can say its observations, its definitions, and measurement of subject, for example, for our interesting, for example, system, like social and economic system. Maybe another example, we can analyze situation, this some technical system, and we can task this problem, this cybersecurity in this information system, like example. Next, we can say about hypothesis. I propose to see, you can see about hypothesis. We can say about theoretical, practical explanations of observation and measurement of the subject. So, like example, this our system, social and economic system. Do you remember about idea? For example, we can form many indicators. We can form great databases. These many indicators about labor resources, about technical situation in this area, information about equipment, information about material resources, energy resources, financial resources for using different technology for example, for building sector, for industry sector, and for information and communication sector of our country, for example. And we can analyze tendency. We can say about tendency. It's a very important idea because by using information about tendency, we can say information for future, for example. And about hypothesis, by using on the next part of my lecture, we can say about these mathematical approaches. We can use, for example, we can describe by using linear function, and more complex situation, we can use non-linear functions. It's more complex approaches. By we have 2 hypotheses: linear function for analysis situation in development, and non-linear function for describing the situation in development in social and economic system. So after that, we can say about this hypothesis, and maybe we can compare linear, non-linear function, and to find more right weight for analysis. So next, after hypothesis, we can use predictions. On the next slide, you can say predictions as reasonable, including logical dedication from hypothesis or theory. For example, we can say about theoretical approaches, we can use mathematical functions for describing of some ideas. And next, it's theory, it's the good idea, but we need to form experiments. So I propose to go on and go on next experiments, next aspects of experiments. For experiments, what this test of all about? For example, we can compare, for example, situation in real economy, maybe in real social and economic system, and we can use, for example, in complex characteristics, many indicators, indices, we can form hypotheses, predictions, and experiments. Next part, I propose to say about essential elements of scientific method in general. So for this part, the essential elements of scientific method are operations, observations, models, and utility functions for estimation models. I propose to describing, we can say about mathematical models first of all. So according this idea, I propose to say about every components of essential elements of scientific method. First of all, we can start these operations. For example, the essential elements of scientific method operations. On this part of my slide, you can see step by step about these 4 elements. So operations, some actions done to the system being investigated. For example, we can use by using operation this our mathematical program soft for describing, and for example, like example, this cybersecurity. Maybe we can use different operations and we can describe a technical system by using some language, program language, and to use many operations for forming program soft. Next, according observations, next essential elements of scientific method, observations. And we can say about what happens when the operation is done to the system. So we can analyze different situation with our system, and I can add next example by using my experience. For example, after forming production function, by using great databases, we can use next idea. We can change situation, for example, these resources, and we can analyze situation, these our indicators. I think, for example, we can change maybe price for energy resources. We can change volume of material resources. We can change price and volume of these resources. And we can change this information in function, this our data. And after that, to run our function by using program soft, and we can see what can we see this our function for future. So this observation. So, but for this experience, for this analysis, for these researches and studies of our country and our system, we need models. So Next, I think it's more important, but you can see it's one of these four essential elements, but I think it's very important models, essential elements of scientific method. In general, for example, model, effect, hypothesis, theory of the phenomena in self-surgent moment, for example. But we can use many theory for this. We can form, by using this idea, we can form some algorithm for our research. And after that, it's model of our study. Another idea we can say about some calculations, for example. I can form algorithm of calculation production functions. It's model too. But for analysis, it's very important to form mathematical model, like production function, like other models for optimization, for example, and many interesting examples for analysis. By using mathematical model, we can compare situation in a country. We can change information, for example, these resources, and can analyze situation for future. So by using these experiments, this analysis, we can form a database for decision making in future. For example, it's very important model, and moreover to form mathematical model for analysis. Next, about number 4, estimation. You can see estimation models, for example. We can use utility function for estimation models. We talked about that, for example, and utility function for estimation models, measure for useful of model to explain, predict, and control. And one of elements of any scientific utility function is the reliability of the model. It's very important. It's very important for analysis and for using this model and this function for analysis and for forming decision making, for example. I see method, I see questions. Okay. Aspect of methodology. Okay, I see questions to me about methodology. I see. On the next, okay. On the next slide, for example, I can say about these questions, for example, on the next, please, for example, about pragmatic scheme of scientific researches. For example, I can say about your questions. And we can use, for example, how does scientific method work? How we can organize these researches, and how we can to form these formulas and these functions. I propose about this scheme, for example, we can say about some stages of researches. And for example, about first step of our researches. First of all, on first step, to using the scientific method is to have some basic for conducting your research. This step is based on observed phenomena. And for example, many examples I told about, for example, we need to analyze, and you might have observed the economic system. Another example, for example, technical system. Another example, for example, social system, and many combinations. Next step is to form a hypothesis to explain some aspects of your observations. For example, we can form great databases with many indicators and indices, like complex indicator. And we can say about some tendency. For example, we can use hypothesis by linear tendency, and next hypothesis non-linear functions. On next part of my lecture, we can say about this theory and about forming linear and non-linear functions. This part, for example, after these steps, I propose I change my screen on next part by using these mathematical models and this methodology. And next step, like final step, we can say, final step of scientific method is test of your predictions. And very important aspects. You cannot prove your hypothesis. Very important, can only fail to disprove it, for example. And after that ideas and the theory, I propose the next pragmatic scheme of scientific researches. For example, first of all, we defined a questions, maybe only one question, maybe we have only one problem, maybe we have more complex idea, for example, like example to analyze social and economic development of regional of our country and maybe our country in general. Second, we need to form information bases, for example, gather information and resources, observe, for example. We can say about resources, for example, for analysis, like example analysis, social and economic system, material, labor resources, energy resources, and many indicators about social and economic system. Next, on the next step, we can form an explanatory hypothesis. So we can analyze tendency. These are our indicators during some period of time, some years maybe. Maybe some indicators, sometimes according my experience, we can start by using information for every month. After that, we have more base about indicators, and we can analyze information for years, for every years. Next. On the next step, we can test our hypothesis by performing an experiment and collecting data. We can add information, for example, on the first step, we need to analyze by using 6 years, but after that, we need information about 10 and more years. Next, analyze the data. Next step, interpretation data and draw calculations, for example, by forming new hypothesis. And after that, publish results and retest, for example, our researches. Dear colleagues, dear students, it first part of my lecture. It first part, we told I change on my first plan about questions. So we talked about basic determinations. We told, for example, I repeat, it was information about science, scientific knowledge, scientific research, scientific method, and methodology. Next, we told elements about main elements of scientific method. Do you remember about this information? About information about characteristics, about hypothesis, prediction, and experiments. And last, by using information, we talked about this plan step by step. We can form pragmatic scheme of scientific researches. Because main important, I say about this information, we can form models. We talked about that. We talked about main 3 steps. I think about first, it's a more complex idea. About next step, we can use about forming hypothesis, and about scientific method. And last, we talked about pragmatic scheme of scientific researches. But now I propose to use another idea, and I propose to say about forming models for analysis, and I propose to say about very important part of our research. We need to analyze correlations between many factors. I told you by using my experience this analysis, economic and social development in our country, and we analyze situation in development on every regionals of our country by using many indicators. For example, in complex idea, we need to use resources, for example, material, energy, labor, financial resources, and we analyze situation this economy on regional level and on country level. For example, we analyze on every regional level. We need analyze situation, this volume of production, this profit for every area. For example, for building, for communication sector, I think building sector, communication and information technology sector, and for example, industry, for financial sector and others sectors of economy. And after that, we need to analyze situation on the regional level and on country level. For that, very important to form these models. I propose to use and analyze now research of correlation and regression models of systems. And according my plan, I propose first of all to say about dependent phenomena, which include the correlation, by using some examples from my theory and my experience. Another to say on the second step, to say about correlation relationships between variables, and to say some words about a simple regression theory and how we can use this simple regression theory for complex functions and complex models for analysis. So, first of all, I propose to say about situation, these dependent phenomena, which include the correlation. So, like this example you can see on my slide, for example, I propose to you, dear students and my colleagues, to say about law of demand. For example, you can see this graphic interpretation between price and quantity of goods. And we can say about, by using this example, between price and quantity, I propose to use the law of demand and to say about the correlation between the demand for a product and its price. For example, this determination, this law, we can say about law of demand. Another idea we can say about relationships between price and quantity. It's the same, for example. In scientific theory, we can use law of demand. And law of demand states that if all other factors remains equal, for example, in our country, we can say about situation, this political situation and many factors. We can situation this, for example, situation this climate change, this change in economic and political situation. So we can say about all other factors remain equal. We can say about only two factors, price and quantity. So you can see the higher the price of a good, the less people will demand that good, this product, that good. So, for example, in point A, you can see by using price P1, you can see we can buy our product, the good, by using quantity Q1. For example, for situation by price, for example, you can see P3, so it's less price. This compare P1. You can see this point C and quantity Q3 more than Q1. So idea about this correlation ship, and we can say about correlation between the demand for product and its price. For example, the less price we can buy more our product, the high price, for example, P1, we can buy less, for example, Q1. So we can say about demand relationships. This line, this green line, you can see on this graphic interpretation in my slide, you can say, and this function demand D for this situation, we can describe by using linear function, for example, like in this example, and we can form this relationship between these two parameters, between price and Q, quantity, by using, for example, in future on the next step, by using linear function. Next, about this more information about correlation between quantity demanded Q and price P. What can we say? I repeat on this slide this graphic interpretation. These points A, B, and C on demand curve, for example, on this line, For this example, you can see line. And for example, we can analyze next. Each point on the curve reflects a direct correlation between quantity demanded Q and price P. So at the point A, you can see quantity demanded will be Q1, and the price will be P1. Also, for example, for point B, by price P second and Q, you can see next, and for example, the next price P3, you can see point this C and quantity this Q3, for example. So this demand relationship curve illustrated the negative relationship between price and quantity demanded. So we can say this information. More prices, less quantity. So we can say about negative relationship between these two variables, these two parameters. And next idea we can say about this relationship, this law sometimes. Another idea, we can use correlation between parameters, and we can say the higher the price of a good, the lower the quantity demanded, A, for example, and the lower the price, for example, you can see P3, the good will be in demand C. So you can compare this point A and point C, price P1 and Q, and for point C, price less than for point A, and but you can use more Q in compare for point A. So we can say about this situation, correlationship between these parameters, price and quantity. And next idea we can say about negative relationship. Another idea, another situation and example, please. We can analyze supply and price of product. You can see another situation. Sometimes we can analyze for supply. We can use information about price and quantity. But situation another, we can use sometimes the law of supply. Another idea, we can say supply relationship between price and quantity. Another situation, another tendency, for example, you can see blue line supply. And we can say about next, like the law of demand before that. The law of supply demonstrates the quantities that will be sold at the certain price. Another situation. But unlike the law of demand, the supply relationship shows an upward slope. This means that the higher the price, you can see P1 next, more higher P second, and more higher P3. This means that the higher the price, the higher the quantity supplied. So you can compare these points A, B, C. You can see P1 more P2, P second, and P3, and by quantity of goods, quantity of product, you can see another tendency. More information about these correlationships and this law of supply by using this idea. I think about, let's analyze direct correlation between quantity supplied Q and price. You can see this line, for example. So sometimes for this example, it's a simple example because you can see a line. Another situation in real life, we can use non-linear models. But for explanation, for analysis of this situation, we can say about a simple line. But I can use supply curve. Another idea we can say about supply relationship. For example, on this line, on this supply curve, you can see points A, B, C, and each point on this curve reflects a direct correlation between quantity supplied Q and price P. And at point B, for example, and maybe point A, you can say about price P and quantity Q1. And for point B and next C, you can see more P3 and for Q more than for first, for example. So we can say about tendency and we can say about another situation. We can compare for first, I change my screen, for example, about law of demand situation negative, and last graphic interpretation for law of supply, another tendency, positive correlation between parameters. And according analysis for our correlation relationships between variables, so we can say about two aspects. We can say about negative and positive correlations between parameters, between factors, we can say. And it's very important. First aspect, a correlation. What is a correlation? It's a measurement of relationships between two variables, two parameters, two factors, for example. By using information of my first part of lecture, we talked about my real experiments and my real researches, scientific researches about different kind of resources in real economic system, material, financial, and energy resources, and indicators of functioning of our economic and social and economic system. For example, volume of production. We can analyze, for example, profit of system. Another idea we can say about this key indicator in GDP, for example. But on the level, these only two parameters, only two variables, we can say about correlations between two variables. But very important for analysis, we can use this theory for analysis more complex system. I think about analysis negative and positive correlations between parameters. So we can say about positive correlation is a direct relationship. The relationship you can see on this slide positive, where as the amount of one variable increases, for example, on this x, first x, and the amount of the second variables also increases. We talk between Q and price, for example. So we can say for supply, a law of supply. Another negative tendency, negative correlations for in general, for example, in the negative correlation, as the amount of one variable you can see goes up, but levels of another variables go down, for example. So another situation in analysis is positive. So very important, we can use information, but a real situation, this I change on first slide this example, for example, by example, this quantity and price. You can see this negative situation, and another for analysis we can use for supply. For example, for production company, it's very important to analyze price and quantity for a real market, and to study this situation, this law of supply. But our behavior in market for customers, I think about that. We need to analyze law of demand, for example. This higher price situation, this quantity, another. And by using this information, last slide I return for negative and positive, I propose to say about very important information we can use, and we can calculate this Pearson correlation coefficient for analysis correlationship between parameters, between factors. For example, this correlation coefficient, we can use for analysis relationships between parameters, and we can use Pearson coefficient correlation coefficient. We can use for analysis. Sometimes we can say about linear correlationship between some variables. It's very important for forming linear functions, and for analysis, for calculations on the next slide, we can use these formulas. For example, before using these formulas, we need, for example, our hypothesis, for example, it's our hypothesis for existing, for example, relationships between our variables, linear, for example, a linear function, a linear tendency, and we need to say about level of this correlationship. So by analysis this level, we need to calculate correlation coefficient. So we need to form some databases, these factors X, for example, and analyze situation, this next factor and indicator Y, for example. And by using some information, like my example, for example, we need to analyze, for example, we need to use maybe on first step for forming complex model, we can instant X for factor. We can use information about all resources. So we can combine information about energy, about material, about labor resources in general. So, and next for analysis our region, for example, deploy region. We can use instant Y. We can use volume of production, for example, and we can form relationship between resources and volume of production. And for analysis and say about a relationship between these parameters, we can use correlation coefficient between these variables. So by using this formula, we need to form next aspects. I see. But maybe you can translate in English, please. Please, I see maybe some information in chat, but I ask, please, dear students, dear colleagues, maybe you can ask me in English. Okay, thank you. So I change in 1 minute before slide about correlation. So we can form for a real situation these calculations. Before that, for example, we use Excel. We can form a database, this information, this X and Y, and after that we can form formula for calculation this correlation coefficient. After that, on the next step, you can see it's from it's information from theory about correlationship and for analysis correlationship between parameters. We can see this number between 0 and unit. And for example, before plus minus 0.3, we don't say about correlationship between parameters. And moreover, I can say for situation these parameters on the level 0 before 0.3, and maybe we can say about weak correlationship between parameter on the level this correlation coefficient between 0.3 and 0.5. You can see on this level. And for these parameters, for example, we don't use these parameters on the next modeling. For example, we can analyze situation. For example, we can analyze, like example, on the first step, very important to say about correlationship between different resources. For example, on first step, I can analyze and say about correlationship, for example, material resources and volume of production and maybe profit of a system. Next step, I can say energy resources and indicators instant Y, profit, and maybe we can say about volume of production. And next, for example, next X, for X, we can use maybe information between labor resources and volume of production and maybe profit. So according these parameters, I can analyze and I can calculate this indicator, this correlationship. Next, you can see about moderate correlationship. If we have correlation coefficient between 0.5 and 0.7, and we can say about strong correlationship, for example, between 0.7 and you can excuse me. Excuse me. And 0.7 and unit. For example, we can say about strong relationship between parameters. On the next step, so after calculation, this correlationship, this coefficient of correlationships, we can say about next. For example, we told about information, this information in table before this slide. But next information, we can say about this information by using signs plus and minus. For example, you can see, for example, plus unit and plus maybe another number. For example, we can say about increasing linear relationship. We can say about positive tendency. So X and Y, for example, like for law of supply, for example. Another situation, for example, this minus unit and instant unit, another information, I think about maybe 0.7, 0.6 and another, but we can say about signs minus. So in case we have this minus, in case of, for example, negative linear relationship, so negative situation, before that we talked about law of demand. And for example, some value between -1 and +1 in all other cases, we can say about different level. For example, I return in my table. For example, you can say information this is table about quantitative criteria of estimation of degree relationships. So we can say about different information. I think about analysis strong, moderate, weak relationship between parameters. It's very important. Before that, for example, and after that calculation, for example, I can say on this graphic interpretation, you can see, for example, this information between parameters, you can see like this, for example, we can say about a linear positive tendency. Our hypothesis in this situation, we can say about linear tendency, linear and positive tendency. After that, we can use, for example, our formula, this correlationship. For example, like this, you can see 0.82, you can see. So for this situation, and I change on my table, it's situation, this strong correlationship. I change on this slide. Next, you can see situation B. You can see tendency, this our information, and you can see it's the same like we told about demand, law of demand. Do you remember from our first slide of this part of lecture? So you can see these points, green points, and after calculations, we have, you can see point 0.7. I change on my first slide this table, number one. So we can say, for example, on level strong correlationship. So it's very important. For example, we can say on this situation A and B, we can say about hypothesis aligner, for example, and you can see, we can say about tendency, positive tendency, negative tendency, positive correlationship, negative correlationship. And by using this indicator, we can say about level of correlation, strong, moderate, and next. Let's to analyze C situation. You can see we don't have any ideas about hypothesis. And after calculation by using correlation coefficient, you can see 0. So we don't have any correlation between parameters. I change my on my table. You can see it's before 0.3. We don't have any relationships between parameters like this. And next D and E, you can see another situation. For example, you can see it's very important. It's very important. For example, you can compare this first A and B. For example, on A and B, for A and B, we can say about some tendency, we can say about hypothesis linear model. Another situation, for example, this D and E, this linear coefficient correlation, you can see about number 0 and 0. But our idea, you can say about non-linear relationship. So it's mean we need to use another formulas, and we need to find another non-linear relationship between these parameters. But for non-complex situation, we need to analyze, for example, this simply relationship theory, and we analyze situation between parameters by using linear models. It's very important for economy, for non-complex situation in general. And on the next step, I propose to you to say about this theory for analysis different relationships between parameters, and to use for explanations some phenomena, for using these formulas for future, and before these very complex mathematical models, I think about non-linear models, we can use linear models. And we can use these linear models for explanation of different phenomena in our life. I think about economic system, social system, technical systems, and others. So on the next our number 3 point, I propose to say about this simple regression theory. For example, for analysis, but I can say simple in general. We can use these words means we are working in 2 dimensions. So we can use you can see only 2 variables. For example, instant x, for example, I propose to say about like example, we can use information about resources. Instant y, our function, we can analyze production, volume of production, we can analyze profit, we can analyze for level of country indicators like GDP and so on. For example, it's very interesting situation. Moreover, maybe now we can say about a simple regression theory, so only 2 variables, but more interesting for forming more complex function for analysis situation in country. I told about example production function, for example. It's very important to use more than 2 variables. For example, very important for every economic and social and economic system to say about capital and labor resources in general, and say about instant y, to say about, for example, situation this GDP on level of country. So we have instant only 1 variable x. We can say about x first and x second. X first, it can be capital on level of regional, maybe on level of country. And next we can use labor resources. X second, it can be labor resources. So we can say and we can analyze by using before forming complex production function. We can analyze situation between correlationship, for example, capital and GDP, and labor and GDP. After that, we can say about level of relationship between capital and GDP and labor and GDP. So we can start this using this simple regression theory. After that, we can say about forming complex models, like my example, for example, to forming production system, production function, and analyze situation in future. What can be if we change, for example, situation, this capital, I think you can analyze situation, this investigation in economy, investigation in enterprise, maybe in some sector of economy. And another situation, I took part this international webinars, this artificial intelligence. I think you know about that. And we talked about artificial intelligence in future. We can stop this idea and this sector of economy from information technology. And but we can analyze labor resources. It's very important because before improving different kind of control system by using some artificial intelligence. And after some years, for example, we can use robots, we can use different control system. Do you remember car without people? And many examples. But we can change information in our country, in our world, in general, by using labor resources. For example, before artificial intelligence and different ideas, we have more volume and we need more volume of labor resources. After improving different control system and automated system and artificial intelligence in different areas, we don't need more labor resources. So, but we can analyze what we have after that, after this changing this capital, we can change volume of capital, and we can change volume of labor resources. We can analyze. It's simple, but it's simple because we say about only two variables. But some of this theory, it's not simple. It's very complex system by using many functional and mathematical functions and analysis, and we need to form great basis. So, but information we can say, like I changed before slide before that. So you can see the tendency like this. For example, we can draw this line, for example, and for this and we can draw this line like this, and we don't draw, for example, it will be not correct for situation this D and E line. You can draw for D and E non-linear regression model. For example, you can see non-linear. For this situation, it can be line, but for situation this D and E, it's a non-linear model. But I propose to say about this theory. For example, you can see on this plot, on this graphic interpretation, for example, like example before that, you can see points. You can see these points. If, for example, you can imagine we can analyze the instant X, maybe some resources, and instant Y, we can analyze maybe situation, this volume of production. So what can we do this theory? You can see, I propose to you to describe this situation by using a linear model. Another idea, I can say question like this. It's line, it's model, it's question line, for example. But very interesting, you can see on this information graphic interpretation, you can see information about A, you can see this line, and we can say about intercept this line, this tendency, this X, Y axis, for example, you can see A. For example, we can say about this distance A. It's intercept between X, Y, and this line. linear model. And next, you can see these units and this distance b. Yes, so for analysis, we can use about the slope of this line, it's b, for example. So you can analyze, you can see on this graphic interpretation, but for real practice, for example, you can image, for example, I talked about we can analyze energy resources and volume of production, material resources and volume of production. So instant X, I repeat this idea, instant X, we can say about resources, instant Y, we can say about volume of production, for example, maybe profit for enterprise, for regional economy. What's very important? For example, we need analyze on the some about information. We can use information about some years, and we can form and we can see tendency, positive tendency. And we can analyze situation in our market and our production, our goods from this sector of economy. It's very important production, and we can analyze situation for future. We, for example, we can investigation in our production. We can buy, for example, new equipment, and we need to for example, expand our production and to prepare more products, more goods for market. So we can increase, for example, on unit of our resources, and we have more our Y, our products, our profits. So we can analyze this tendency for future. We can say for positive tendency, and this information we can use for decision making for future. Next, for this, so for a real using of regression line, we can use, for example, like my explanation. For example, yes, we can use our regression line, instant regression line. I can say our regression model. I can use mathematical model for prediction for future. And next idea for analysis for studying of our situation, we can use for interpretation of simple regression results, for example, by using what kind idea, for example, very important in our country, for example, but I think for every economic and social system, for example, we can have more volume of resources and we have less volume of resources. By using these models, we can say about interpretation of tendency for future, by I think for growing of production system and another not positive tendency too. For example, next, for example, we can say about prediction. For example, you can see information like this. You can see, for example, instant X for real situation, it's our sources. Instant Y, it's our indicator about volume of production, profit, and others. And you can see, for example, we can have more resources in future, and questions about prediction of our indicators. You can find, for example, I return in 1 minute on slide like this. I can use this formula and instant X, we can change this X plus delta X, for example, for increasing of our system. And I can find new Y, new volume of Y, for example, by using this formula. I change on this slide. So it's an idea for analysis for about using of regression line for prediction. It's very important. And after that, it's this information we can use for decision making of our economic and social and economic system by using for explanation and for real idea for production function. Do you remember capital and labor resources? It's a very important idea for analysis. We can analyze, for example, information this capital. We can analyze situation this capital by using information this different investigation program and so on. We can change situation this our equipment and capital in economic system, and situation for our current situation, future situation. This artificial intelligence and information, these labor resources, for example. We need to analyze this capital and labor, and we need to analyze what have we in future, this production system and volume production and profit. And by using these approaches, we can use for analysis about information for country in general. So instant Y, we can use information about GDP. So, and we can analyze situation with GDP. You know, this indicator, it's more important indicator for analysis and analyze situation, this development of every country in our world. So this idea we can use, for example, for current situation, and we can use these approaches for analysis in future. Next, you can say about you can use this idea for interpretation of simple regression results. For example, I say about this by using example these resources problem. For example, I think you know about our country problem, these energy resources. For example, we need more energy resources for industry sector, for example, but it's problem for these energy resources. But we can say, and we can change this information for future. We can change information this X, and we can use model, regression model for some sector, for example, and we can analyze situation what what can be this y for changing, for example, of unit in resources, and we can analyze this profit, this GDP on the level of country, and by using this information for different level, regional and level of country. And next, about this information, so you can see on my slide, like example, linear model. So we can say in a process of modeling, I think we have, for example, information this X, and we have information this Y. But our task to calculate parameters of our models. For example, it can be A0 and A1, A first, the parameters and our coefficient of linear models. And for example, for calculation, this we can use this method. We talked about different methods for modeling, but for analysis and for calculation A0 and A first, we can use, for example, least squares method. Moreover, I can add information. We can use instant X, but X, it's independent variable. For example, instant X, we can use different resources. And for analysis Y, Y, it's function from independent variable. And we can say Y from X, it's dependent variable. So for real situation, we can use this method, least squares method, for calculation parameters of model and forming this mathematical model dependent variable as function, dependent variable as function from independent variable by using. And according this method, maybe it's another idea for examples and information about using this method, for example. But main idea, you can see, for example, we can form some database. This information, this X and Y. Like example, we talked about this example, resources and GDP, for example, on the level of country. Another situation for every enterprise, we can use this approach. We can use for analysis development of regional level. So energy and volume of production, energy and profit, for example, and so on. Next, our task to form our theory function. So we can describe this information by using linear models. For example, like we talked about before, this line, formula, question, line. So our task to find the best line and our task to calculate parameters of models. We can use this information about the sum of squares, and this idea, it's very important to find this information about our information about our real situation and our function. So by these questions. And the least squares method you can see by using this indicator, and we need to find optimization, minimization, for example, function, minimize for analysis of this sum. And after that, we can use, for example, to change, and very important, I return for our coefficient determination, and we have very important by using this indicator, to find the best line for analysis. So according our at the end, so we analyze dependent phenomena, this including the correlation. We told about correlationships between parameters and told this view about regression theory. So thank you, and maybe we have questions. I think questions in okay. How can we delve into various aspects of methodology of scientific research and elements of scientific method? Class lecture. For example, I can say about able to provide a lecture, especially focusing on fundamental elements on the scientific method for our class. Yes, I have many examples about using this information and real. For example, I can say for my students, Ukrainian students, I have this course, and we have this practice. We can use this course for international students in our university. And we have many practices this using this methodology by calculation, these coefficient correlations, and by analysis different situation in technical for technical problems, for economic, and for social problems. So Novita, maybe we can have continue our project, yes, and we can. I have only 2 hours, and idea was about these approaches. We can continue.
Yes, Miss, we can continue in the next year.
Mm-hmm.
Yeah.
Mm-hmm. Mm-hmm.
In the next year of January, it's okay.
Mm-hmm.
Yeah.
Okay. And we can say about many examples for a different situation. For example, for level regional economy, for level, it's simply a regression theory, and we can say today only idea to find relationships between only 2 parameters. But I told you about more complex ideas, for example, for production function. For example, instead 1x, we can use x1 and x second, capital, for example, and labor resources. And by using, for example, like this example, we can say about and next like this. for example, only 2 parameters, linear models. But a more complex idea, more complex calculations we can use for non-linear models like this, like D and E. And on the next idea, to combine, for example, for example, for analysis resources for X between, for example, material and profit, we can use a linear function, for example. But for energy, for example, and profit, maybe we can form non-linear models. And our task to combine this different function for one-to-one function, to complex function for analysis, like this. And after that, production function, it can be a non-linear function too, for example. Maybe do you have questions? So it's great analysis, and this methodology we can say about this example on a real situation. For example, I change in 1 minute. We talked about, do you remember about my first, today we talked about only theory methodology like this, for example. And for example, we can say about questions, for example, to investigate economic situation in country, maybe on some enterprise. We need to form databases. We can analyze and we can say about some hypothesis, linear, non-linear tendency. After that, we can use analyze data, for example, by using correlation theory, like information about my second part of lecture, this correlation theory. For example, simple correlation theory, if for situation, these 2 variables. And next, we can form some models, and after that, we can use this model, maybe models, for analysis for future.
Is it enough for answer, Miss?
Yes, do you have questions?
Oh, okay. I think we don't have no more question again from our participant, Miss. Okay. Yeah. Thank you so much for this time. Before I close this event, for our participant, please open your camera. I will take a picture on the count of 3. 1, 2, 3. Okay, another one. 1, 2, 3. Smile, thank you. Thank you for your keen cooperation. Finally, we come to the end of visiting lecture today. We would like to say to me, thank you for Miss Olena for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future with University, Custom and Finance, the visiting lecture for today. And here we hope to see you soon. Thank you and have a nice day. Thank you so much for Mr. Olena. Thank you.
Thank you. Thank you. I can say it's very interesting to work with you. It's very interesting to take part in webinar. This information about artificial intelligence and deepfakes. It's before in summer. It's very interesting to work with you, and I can say it's very interesting to continue collaboration with our university. and to take part these lectures and this our practice, and maybe you can continue, and maybe you can compare. And you can prepare our scientific articles and say about our researches, and it's very interesting to work with you. I say thank you for participation, and I think we can continue our work, these lectures and this different maybe practical training too. Okay, thank you.
Yeah, thank you so much. Thank you. Bye-bye.
Thank you, Madam Olena. So beautiful.
Yeah.